Hey, great to have you here today to learn about atoms, molecules, and compounds. Everything is made up of atoms and molecules and compounds. The most basic building blocks of matter that we're going to learn about, and it's very important you learn about it because, heck, you're made of atoms. You're made of molecules. You are made of compounds. So this is critical. Now, the atom is made up of several parts, including the nucleus, which is the center of the atom, and that contains the proton and the neutron. Orbiting that nucleus is the electron. The electron is negatively charged. The proton is positively charged. Neutron, no charge. So, next, we need to think about a couple other things. One being that the model of the atom can vary because we can't see it. So scientists have to come up with a lot of different ways to talk about the atom. And we use these models because we can't see atoms. Now, we know they exist because we've done lots of experiments to kind of show the parts of it, and the story behind that's really interesting. But what we need to focus on right now is that the atom can be represented in a lot of different ways. Each atom has some good and bad things about it. So you can see here some basic Bohr model atoms. And these Bohr models are great in that they kind of show where everything is. The one on the left here actually has it labeled. The one on the right, not so much. But you can see the protons, the neutrons, and the electrons and their positions. This is the periodic table, and the periodic table has all of the elements on it. And every year they name a few more, it seems, these days. Now, we're going to learn mainly probably about the first 100 or so. And no, you do not have to memorize the periodic table. Just know that these are all the different types of atoms that there are. Now, on the periodic table, you'll notice all those letters. And those are the atomic symbols. And we use those to represent the different types of elements, the types of atoms. And so when we look at the periodic table, we can tell that Fe, for instance, is iron, He is helium, and O is oxygen. Now notice it is very important that we capitalize only when necessary, because that first letter is always capitalized. That second letter, if there is one, is lowercase. And that makes a big difference when writing out chemical formulas. So the chemical formula is when we have molecules and compounds, we have atoms stuck together. When they're stuck together, we got to be able to represent them with letters. So we can use a two-dimensional surface like a piece of paper or a computer screen to show what we mean by what molecule or compound is and what elements make it up. So some terminology. First, we have that symbol, and there's numbers after that symbol, and those are called the subscripts. And we'll have H2SO4, which is the example on here, and H2SO4 is sulfuric acid. It contains 2 hydrogen, 1 sulfur, and 4 oxygen. Notice that there is no 1 after the S, but it's still 1 because there's just 1 there. It's just understood it's 1. We don't have to write the 1. There's an S there. There's 1 S. That means there's 1 sulfur. This is sugar, glucose, C6H12O6. 6 carbons, 12 hydrogens, 6 oxygens. You're kind of getting the idea here. That number after the letter tells us how many of what's before it. Okay, so remember that. Next, what are molecules and compounds? They're very similar, slightly different. All right, I'm going to go for the very basic definitions for these. Molecules are just combinations of atoms, either the same or different. Compounds, different elements combined together. We already learned that this year. That should be familiar. So 2 different elements combined together is your compound. A molecule could be O2, it could be H2O, CO2, CH4. So all those are compounds, but they're also molecules. So multiple things put together are molecules. Now, how do they form? Molecules and compounds form because of the electrons. The electrons on the outside either get taken away or they get shared. And that's how they like to be. Those atoms like to have nice full orbitals, so they'll share or they'll take electrons from other atoms. So, you're familiar with this? You know it? This is what it kind of looks like here. If you're looking at H2O, you'll see that the oxygen combines with the hydrogens. Those outer electrons get shared. It becomes H2O. All right. So these are some other representations of compounds. Right. And I just wanted to show these to you so you have an idea of when you see these in books or online, you know what they mean. They're just representations of compounds, not necessarily in our regular chemical formula way, but they try to represent it in more a two-dimensional or three-dimensional structural model. And that is all you need to know about atoms, compounds, molecules. That's it.